Let's read the question. Let the straight line y is 2x touch. Okay, so let's first draw the line. As soon as you read it, you just draw it. Okay, so y is equal to 2x. So that is a line with slope of 2. Okay, so that's your line. Y is equal passing through the origin. You know that. So this is your line. Now touches the circle with center 0 alpha and radius r at the point a1. So let's draw that. So this point is on the y-axis. Okay, so let's say the point is here somewhere. Okay, so 0 alpha, and now we will draw a circle such that it touches the line. Okay, somehow let me make it touch like that. Okay, so this is the point where it is touching. They are saying is a1 point. This point is 0 comma alpha. Let's name this point also. Let's call it p. Let's read next. Let B1 be the point on the circle such that the line segment A1 B1 is the diameter of the circle. So this point, okay, so here A1 B1 is the diameter of the, you know that. Now what? A1 B1 is perpendicular because it's a tangent, right? Radius vector is always 90-degree here. Okay. Let alpha plus r is this. Then they're asking for alpha r A1 B1 so on. What do? First we do the very obvious thing. Okay, so we just figure out that what is r. Okay, how do we get that? See, from this line you are dropping perpendicular to this line. Okay, you know the formula, right? So this is your point p. Okay, from this you are dropping a perpendicular on the line 2x minus y is equal to 0. Remember the formula? The length of the perpendicular is what? Modulus of a x1. Okay, so instead of x you're going to plug in alpha, plus b y1, instead of y you're going to plug in beta, and there is no c, so just that, upon under root a square plus b square. This is your a and your b is minus 1, so a square is 4 and b square is 1. So what do you get? So alpha, you see that alpha is positive. Okay, so I just remove the modulus and say that this is alpha upon root 5. So what do we get now? That alpha is root 5 r. Now what? They have given something, right? You just plug in there. So alpha plus r is equal to 5 plus root 5 they have given us. And we figured out that alpha is root 5 r. So then you got the value for r. You can just get r outside. So root 5 plus 1. Here also you can take root 5 outside, root 5 plus 1. You can divide by root 5 plus 1. So you got your r to be root 5. And then if r is root 5, what is your alpha? Alpha is 5. So we solve both of it, okay? R value and alpha value. So r is root 5, right? Yeah. So this is root 5 and alpha is 5. Okay. Now they're looking for A1 and B1. Okay, so I need to figure out what is coordinate of A1 and what is coordinate of B1. Now, if you're clever, you will just look at the coordinates what they have given. So A1, can you see it's always in the positive quadrant. Okay, so none of this is saying that the both coordinates are positive. So like this should go to here, right? Similarly, if you look for B1, okay, of course x coordinate has to be negative, right? And little more than whatever coordinate you have here. You see that coordinate is 4. It's little up, right, on the y-axis, so it should be this one. Okay, see, but let's solve it. Okay, completely, don't worry, we'll solve it completely. So r and alpha we got. Okay, now if I want to figure out what is the coordinate of a1, what do? There's so many ways you can do that. Okay, one thing you can do is you just write equation of this line, because you know that the line a1 b1 is, so line a1 b1 is perpendicular, right, to this line. So what should be the slope? What should be the slope? Negative reciprocal, right? So slope is 2 here. So negative reciprocal is minus half here. Okay, now write the equation of that line, y minus y1. So y minus, now you got this coordinate, right? It is passing through this point. So that point is 0 comma 5. Alpha is 5 we got. So y minus y1 is equal to m x minus x1. That's your line. Okay, so what we get is y is equal to minus x by 2 plus 5. Now how do I get a1? Solving, right? This is a1 is intersection of this line and the perpendicular line. So for a1, let's figure out the intersection point. So equate the two. Okay, so 2x is equal to minus x by 2 plus 5. What do you get? This is, you just move on to the other side. Plus is equal to that, just reducing a little job. Okay, 2x by 2 is 5. Okay, so you got your x coordinate of that point to be 2. Okay, if x coordinate is 2, then what should be the y coordinate? It's lying on that line, so 4. So a1 coordinate you got to be 2 comma 4, which already we have figured out intuitively. Okay, now b1, how do I get b1, tell me? Okay, b1 is again on this line, right? What other property does b1 has? It's lying on the circle, right? So circle equation is what? The center is what? 0 and 5. So x minus 0 whole square, y minus 5 whole square. What's the radius we got? This, okay, r square. That's 5. Now just solve. Okay, what do you need to solve? Equation 2, this equation and the circle equation. So from here, y minus 5 is x by 2. You see that? Y minus 5 is x by 2. So just plug in. Okay, y minus 5 is x by 2 whole square. I mean minus x by 2, but anyways you're squaring, right? So what do you get? Tell me. X squared plus x squared by 4. 5x squared by 4 is equal to 5, right? So 5 gets cancelled. Your x can be plus or minus 2. You are taking, you are in the second quadrant, so x should be minus 2. Okay, and what should be y? You just plug in, okay, in this line. Okay, so gets cancelled. 5 plus 1 is 6. So the coordinate of b1 point you got to be minus 2 comma 6. So there are multiple ways. Okay, do whichever way you feel it's simpler. Okay, so see you with another question.